So the question is, how many of these molecules are polar? And so we have SO3, OF2, BeCl2, CCl4, and O3. So what we're going to do is the first step is you're going to count out the valence electrons and draw Lewis structures. Then you're going to find the bond dipoles by finding the differences in electronegativities. Then you're going to draw your molecular geometry, and then you're going to find your net molecular dipoles. So we're going to start with SO3. So to draw your Lewis structure, right here, you're going to want to count up your valence electrons, and I got 24. So then you're going to put S in the middle and surrounded by 3 O's. Then you're going to count out your electrons and place them accordingly. And also these lines right here, that's a bond, which counts for 2 electrons as well. So after you create your Lewis structure, you're going to find your bond dipoles by finding the differences in electronegativities. So the O's compared to the S are more electronegative, so they're going to have a partial negative charge here, here, and here, and this S is going to have a partial positive charge. And so bond dipoles go from partial positive to partial negative, so these arrows right here are showing that. So next we're going to want to draw your molecular geometry. So what we have here is 3 domains, 1, 2, 3, and that means that the molecular geometry is going to be trigonal. So you can draw that here, 1, 2, 3, add your bond dipoles here, here, and here, and that's going to be 120 degrees. So we know that this molecule is going to be nonpolar because there's no net molecular dipole, because all 3 of these are equal and cancel each other out. For the next one, OF2. I counted up 20 valence electrons. Then I placed them accordingly. Now F is more electronegative than O, so I assigned them with partial negative charges. So here we have 4 domains, here, here, and then 2 non-bonding pairs, which means this is going to be bent. And you can see your dipole going from positive to negative. So here you draw your molecular geometry with your 2 domains here, F and F, and then another 2 non-bonding here and here. And then you can draw your bond dipoles as well. And so this molecule is going to be polar because the bond dipoles do not cancel out because there are not 2 non-bonding pairs. So they're not equal, which makes it polar. So here we have BeCl2. So I counted up 16 valence electrons. So I drew the Lewis dot structure accordingly, and I assigned 2 partial negatives and a partial positive, which means your bond dipole is going to go this way and this way. So you have 2 domains here and here, which means it's going to be a linear molecular geometry. So you draw it like this, with your Cl's attached to your B, and your bond dipoles going like this. And this is going to be nonpolar because these are going to cancel out, which creates no net molecular dipole. Here we have CCl4, 32 valence electrons. I've drawn the dot structure again. Cl is more electronegative than C, so we have partial negatives with a partial positive, which means your bond dipoles are going to be going this way, this way, this way, and this way. So here we have 4 domains, which makes this a tetrahedral molecular geometry. So here I've drawn that, and we have 1, 2, 3, 4, and your bond dipoles as well. So these are going to be nonpolar because these are going to cancel out. Over here we have O3. We have 18 valence electrons. So I drew my Lewis dot structure accordingly. Here we have partial negative, partial positive, so your bond dipoles will be going this way. So here we have 3 domains, 1, 2, and your non-bonding pair, which is going to make this bent. So here I've drawn it. Your 3 O's, 2 domains here, and your 2 non-bonding pairs here. So your bond dipoles are going to be going this way, creating a net right here. And since there is a net, this is going to be polar. So to recap, the polar molecules are OF2 and O3, and the nonpolar SO3, BeCl2, and CCl4. And some common mistakes that can occur when doing this is forgetting about non-bonding pairs when it comes to molecular geometry. So you might look at this and say, oh, just 2, but you have to remember to include your non-bonding pair, otherwise you think this would be nonpolar when it's really polar. Another is getting your Lewis structures incorrect, which contributes to this, because if you don't count correctly and you don't put, say, your two non-bonding electrons here, then you won't know how many domains you have correctly, and then you won't know how to do your molecular geometry, and then you'll get the wrong answer.